we'll walk you through solving systems of equations in two ways. First off, a system of equations is two equations with two variables. You cannot possibly solve one equation with one variable like this. I have no idea what x and y could be. There's an infinite number of things they could be. But if you have two equations, now you can figure out what x and y are. And that's what we're going to see how to do right now. There are going to be two methods that we learn. The first is called substitution. The way substitution works is, just like the name suggests, we are going to substitute one variable out and replace it with another expression. So let's take a look at this example down here, number 1. Our first step is to solve one of the equations for either x or y. That means get either x or y by itself. It does not matter which one we get by itself. Look for whichever one is easier. In this case, I'm going to look at this equation over here and say, oh, that y is almost by itself. So it should be easy to finish getting it by itself. All I need to do is add 1 to both sides, and that would make this equation y equals negative 2x plus 1, which means anywhere I see a y, anywhere in this system of equations, I can take it out and replace it with negative 2x plus 1. And so that's going to be my step number 2. I'm going to do the substitution that I just set up. Now, it won't really help to put it back into that y. That won't get me anywhere. What I'm going to do is take my expression for y and plug it into the other equation where there's a y. So I will take the equation exactly as it appears, 3x plus 5, and then instead of y, I'm going to replace that or substitute it with negative 2x plus 1. Notice how everything else in that equation, the 3x, the plus, the 5, the equals 4, everything else is the same. 3x plus 5, the equals 4, everything else is the same. It is only the y that I replaced. One note I want to give you about that, and you should be writing down the notes in your notes along with the examples, is that when you do that substituting, make sure you are careful about parentheses. The reason I say that is because this 5 that's right here is going to need to be multiplied times the negative 2x plus 1. If I didn't put a parentheses there, it would be a little bit confusing. So I'm going to start solving the resulting equation. In order to do that, I'm going to do the distributing. 5 times negative 2x is negative 10x, and 5 times 1 is 5. And then we'll just keep solving here. I can combine 3x minus 10x is negative 7x. Please keep in mind that you can rewind and pause this video if I'm moving too fast. And we're going to keep getting that negative 7x by itself. So I will subtract 5 from both sides. So negative 7x equals negative 1. And so x equals 1/7. So our next step is, once we have that done, so we did step 3, we had already done step 2, we had already done step 1, now we'll move over to step 4 here. Once we know what x is, we can replace it. We're going to do another substituting. We're going to replace what we just said x is equal to in for x in the other equation. So I'm going to write everything exactly the same. Or I can actually use this equation because it's a little bit easier. So y equals negative 2x plus 1. I'll rewrite that so we know what we're doing. And then I'm going to take that 1/7 and plug it in for x. So y equals negative 2 times 1/7 plus 1. And that equals 5/7. So my solution, I'm going to make sure to write it together as an ordered pair with the x first and the y second. And that's your answer. I'm going to move along to see a word problem where we use this. And the key to solving word problems here, and a note that you want to write to yourself on the top, is before you can solve a word problem, you need to make sure to declare your variables. That means if you're going to use X's and Y's or any other letters, you need to say what they stand for. There were 130 faculty at a conference. If there were 18 more women than men attending, how many of each gender attended the conference? So we'll start by saying that we don't know how many men there were. We can call that X. And we don't know how many women there were. We can call that Y. It does not matter which one we call X, which one we call Y. You certainly could have used different letters also. Well, if they told us that there are 130 faculty at a conference, they didn't use the word total, but that means the total of all of the men and all of the women add up to 180. They also told us that there were 18 more women than men, so the number of women is equal to the number of men plus 18. And in this case, unlike the last example, I don't have to solve for either of my variables because they already gave me y by itself. So all we have to do to solve now is do the substitution. We're ready to do the substituting already. I can take the x plus 18 and plug it in for the y value right there. So I'm going to say x plus 18 equals 180, or 2x plus 18 equals 180, or 2x equals 162, or x equals 81. I know I do those calculations very quickly. The point is for you to pause and rewind so you can take as much time as you want while you're watching this. Once we know that x equals 81, do the same thing we did with the last case, which is say y is equal to x plus 18. And I'm noticing my problem here. Some of you might have caught it already. I can't read my own writing, or I can't even read what's typed. There was 130, and I kept calling that 180. So I'm going to have to go back and fix all of those numbers. And then we'll just put again the correct numbers here. That was 130, not 180, which means that this should have been 130. When we subtract 118 from that, we should get 112. And when we divide 112 divided by 2, we get 56. And so now I can say that y is equal to 56 plus 18. So y equals 74. And so that means there were 56 men and 74 women attending the conference. Okay, one small point I want to make before we move on to another way to solve these, which is that sometimes you get unique cases. Things get a little bit weird sometimes when the variables completely cancel out. That means in the course of doing your work, you don't just get rid of the x, you don't just get rid of the y, but they both disappear. So two things could happen. Either you end up with an equation that is never true. So in this one, if y equals 2x, I take that and plug it in here, I will get 8x minus 4 times 2x equals 10. And the 4 times 2x is 8x. And my problem here is that 8x minus 8x is 0, and 0 does not equal 10. If you ever get to an equation that can never be true, you have no solution. On the other hand, if you get to an equation that is always true, like in this case, if I take 2x plus 1 and plug it in for y here, I get 2x plus 1 minus 2x equals 1. And my 2x and my 2x cancel out, so I get 1 equals 1. If you get an equation that is always true, that means there are infinitely many solutions. That's the only way you can answer this question. There isn't only one pair of x and y that make the system work. There's an infinite number of x and y pairs. That doesn't mean you can just pick any number and it must work, but there are certain pairs of numbers that could work. Like in this case, for example, if you pick the number 5 and 11, well, 11 equals 2 times 5 plus 1. That works. Or, and it also works in the other one, 11 minus 2 times 5 equals 1. So that's one pair that works in both. Or you could pick another pair, let's say 2, 5. Well, 5 equals 2 times 2 plus 1. That's true. And 5 minus 2 times 2 equals 1. So this is another system of equations where you have there's another solution to the system of equations that actually works. You can come up with examples all day. And so the way we answer this is we say there are infinitely many solutions. Okay. I'm going to go over another method for solving these systems of equations called elimination. Now, we had this in our getting ready for the unit lesson last class. And if we take a look, I'm going to do the second example first. The idea of elimination is sometimes you can substitute one variable out, but sometimes it's even easier if the variable, one variable, will already cancel out just the way it is. So this only is going to help me out if I have my like terms lined up. So that's going to be my first step. I want the x's on top of x's, the y's on top of y's. It's even best if I can have the equal signs on top of the equal signs too. And then what we want to see is that we'll have one of the two variables have coefficients that are opposites of each other. Like in this case, it's 5 and negative 5. This version has the word inverses, but I think your paper version has the word opposites, which is a little bit better. And so what happens when you have opposite coefficients like that, the negative 5 and the positive 5, is you can just add the equations to each other. Which means every like term you combine. It's very important that the equal signs are lined up in order to do this. But once they are, you can just say, oh, 2x and negative 4x add up to negative 2x. Negative 5y and 5y cancel out. And negative 25 and 35 add up to 10. So that means that negative 2x equals 10, which means that x must equal negative 5. I got that by dividing both sides by negative 2. And so if I know that x equals negative 5, I'm up to step 4 here, I can substitute that value into the equations that I started with. And it doesn't matter which one of the original equations you start with. I'll do the one with the easier numbers. 2x minus 5y equals negative 25. And so I can say 2 times negative 5 minus 5y equals negative 25. And now I can just keep solving this. Negative 10 minus 5y equals negative 25. If I add 10 to both sides, negative 5y equals negative 15, and then divide by negative 5, and I get 3. Y equals 3. So my solution is that x equals negative 5, y equals 3. And that's your answer. The catch to this is sometimes neither your x's nor your y's match up with each other. And so sometimes you have to make them match up yourself. And that's what this step in here is, step number 2 that I had skipped over before. Just like when we're making common denominators to add fractions, like we saw in our last unit, the only way we can change the numbers around is by multiplying. But I can multiply, in this case, I'm not going to actually multiply the top row. I can multiply both sides of an equation by whatever I want. And so what I'm going to do is multiply, in this example, the bottom equation. If I multiply both sides by 2, then what's going to happen is those y values will match up. The top one is already a positive 4y. I'm going to leave that the way it was. I didn't change it, so I'm going to rewrite it here. But the bottom one, when I distribute that 2, will be 6x minus 4y equals 14. And now I have what I'm looking for, which is a positive 4y and a negative 4y that have opposite factors, so opposite coefficients. And so now I can cancel them out by adding together. 2x plus 8x, 6x is 8x, and negative 6 and 14 is 8. So x equals 1. And then I can go back to either of my original equations. It doesn't matter which one. 2x plus 4y equals negative 6. And I will plug in that 1. 2 times 1 plus 4y equals negative 6. And from here, we're just solving the equation the same way we did before. And a reminder again, pause and rewind as much as you need in order to be able to do that solving on your own. So we've learned 2 methods for solving here, which means it's going to be up to you to decide which method to use. My recommendation for you is to first, your overall goal is to do whichever is easiest. So if one variable is already by itself, well, that means it is perfect for using substitution. On the other hand, if one variable already has opposite coefficients, like the 4y and the negative 4y that we saw, then just add the equations to use elimination. And then if it's not obvious, if one of those 2 methods is not obvious to choose, so otherwise, your job is to decide which is easier. Either get one variable by itself, or multiply to make opposite coefficients. Whichever one is easier you can use, but it's worth pointing out that you can always use either one and you'll get the same answer.